Hi, my name is Manish Gupta, and in this video, I'm going to talk about how to enable large language models to know when to abstain and not give out a wrong response. Okay, this is one of the outstanding papers at ACL 2024, and let's get started. Okay, so why do large language models hallucinate? Well, because of missing, unreliable, or outdated information. So this causes large language models to not just hallucinate, but also sometimes come up with biased responses while still speaking with confidence, right? So therefore, in this paper, the authors talk about this interesting task of abstain QA, abstain question answering, where the idea is to be able to build some sort of a methodology wherein, given an LLM and given a question, you can basically decide whether the LLM should answer the question or should abstain from answering the question, true or false, so that it abstains. Most of the times it could go wrong, right? Um, so in this video, I'm going to talk about these 11 previous methods categorized into 4 different nice buckets: calibration-based methods, training-based methods, prompting-based methods, and self-consistency-based methods for figuring out whether the LLM should abstain or should it basically just come up with the answer. Okay. And then I'll also talk about these two interesting multi-large language model collaboration-based approaches that these authors have proposed in this paper, cooperative approaches and competitive approaches. Okay, so let's get started. So these are the 11 popular methods to identify knowledge gaps in large language models, and those which can be used to decide whether the large language model should abstain or should basically come up with the answer. Okay. All of these methods depend on a held out set of question answer pairs. Remember, we are talking about question answering as a task, right? There could be a train set, held out set, and a test set, and we are sort of assuming that there is an held out set of question answer pairs such that various hyperparameters in these methods can be tuned. Okay, so let's get started. There are these 4 different kinds of methods, as I mentioned earlier: calibration-based methods, training-based methods, prompting-based methods, and consistency-based methods. Okay, so let's talk about each of them one by one. So there are 3 calibration-based methods: token probability, temperature scaling, and ask for calibration. Okay, so let's talk about them. So what is token probability? Well, you can actually give the question to the LLM, and the LLM comes up with an answer, and maybe it is a multiple choice question, so it comes up with probabilities for each of the 4 choices. And what you could do is to basically look at the probability of the max probability, and then if it is greater than a threshold, then you essentially answer, else you basically abstain from answering. Now, this threshold is basically decided based on the held out set. It is tuned based on the held out set. Temperature scaling for softmax, well, finally, out of 4 answers, if you have to choose one, you basically have a softmax with 4 output neurons. You could basically just use a temperature hyperparameter with the softmax so as to have a smoother output distribution before you apply the threshold. Okay. Third method, ask for calibration. You could basically tell the model itself, hey, provide the probability that your guess is correct after the model has generated an answer. And then based on the probability that it comes up with, you can basically tune that threshold on the probability and decide whether to abstain or answer. Okay. Now think about training-based methods. So, you could basically have the large language model, and on the last hidden layer, you could basically do a linear probing. So essentially, you can just connect a dense layer and a single neuron so as to predict whether to abstain or answer. Now, obviously, these weights need to be trained, and these weights can be trained using categorical cross entropy or binary cross entropy laws, right? So essentially, based on whether the answer is correct or not on the held out set, you could train these extra parameters. You could also train an external verifier model. So this is basically going to be an external model. After your current model has generated an answer, it takes the question, the answer, and then based on the CLS token of this large language of this another verifier language model, you can basically ask it, hey, predict now whether this large language model has hallucinated or come up with the correct answer. Okay. Again, this can be optimized based on the cross entropy loss on the held out set. Instruction tuning. So essentially, again, what you could do is you have a held out set. On the held out set, you could do instruction tuning for the original large language model itself. Now, while doing instruction tuning, what you could do is to basically first just infer as it is from the large language model and let it generate an answer. If it comes up with the right answer, well, use the same answer so as to do instruction tuning. But if it screws up and comes up with the wrong answer, then you replace the wrong answer with an abstain message saying, hey, sorry, I cannot answer this question or something like that. Right. And then you do instruction tuning on this held out set where, correct ones you don't touch at all. Incorrect ones you replace the wrong answer with the abstain message. Okay. So those are the training-based methods. Now let's talk about prompting-based methods, simplest ones, right? So essentially, self-reflect is a very popular method. So essentially, the large language model is given the question, asked to come up with an answer. After generating the answer, the model is asked, the above answer is A, true, B, false, tell me. And if the model basically says B, false, obviously you should basically abstain, right? You could also ask the model to come up with more information after, or ask if the model needs more information to answer the question, right? So you basically give it the question, let it come up with an answer, and then you ask the model, do you need more information to answer this question? Yes or no? And if the model says yes, it does need more information, then clearly the model might have just hallucinated while coming up with the answer. So you should abstain, right? Generate and match. Now, several times when we are asked to do MCQs, multiple choice questions, A, B, C, D, several times we don't know the answer and we just basically choose one randomly. Now, the model could also be doing some same thing. So therefore, what you ask the model to do is to not really choose from A, B, C, D, but actually, ask it to generate the answer. And then, you abstain if the generated answer doesn't match any of the options. But if it matches any of the options, you basically put out that answer. Okay. So that's the prompting-based approaches. Let's talk about consistency-based approaches. So, A, B, C, D are 4 options, but maybe you can also put up none of the above as an extra option. And if the model basically given these 5 options chooses none of the above, then you abstain from answering, right? The next one is self-consistency threshold. So this is a very popular method in general for large language models for various tasks. You let the model basically, you basically generate multiple chain of thoughts. And then you do voting based on those chain of thoughts. So and then decide which is the most voted option. Now, the most voted option, if it is not voted very frequently, then you essentially abstain from answering. So this frequency of the most voted option is basically called as plurality index. So if plurality index is actually lesser than a threshold, you abstain from answering. Okay. Now, those are the existing methods. Now, what are these interesting 2 methods that these guys came up with in this paper? So they basically came up with multi-large language model method. They basically said that, hey, one single large language model can only do so much. Let's have multiple large language models collaborate with each other to improve the abstinence accuracy for your current large language model. Okay. So there are 2 kinds of methods that they propose, cooperation-based methods and competition-based methods. And I'll talk about both of them. Left one basically talks about cooperation-based methods. Right one talks about competition-based methods. Okay. So even in cooperation-based methods, so broadly, cooperation-based methods basically mean multiple LLMs cooperate with each other. And then they try to, the original LLM comes up with an answer to the question, and the others basically try to give feedback about the answer. And then based on the feedback, a judge decides whether the model, the original LLM, should abstain or come up with the final answer. Okay. In competition-based methods, these large language models are competing with each other. So the original LLM comes up with an answer, the other models are asked, hey, can you come with an alternative answer? And then the original model basically thinks based on these alternative answers, should it really still come up with an answer or keep its mouth shut? Okay. So let's talk about these in detail. Cooperation-based models, the cooperation-based method, actually there could be 2 variants, the self variant and the others variant. Let's talk about the self variant. In self variant, what is done is basically the large language model is given the question and it has supposed to come up with an answer. It comes up with an answer. It comes up with an initial answer. Now, the same large language model, you don't really come up with multiple large language models. In fact, you can use just same large language model. You basically tell it, now imagine that you're a factual expert, or imagine that you are a common sense expert, or imagine that you're a math-based expert. You basically take this question and, can you come up with a knowledge paragraph from a common sense perspective or a maths perspective, and then, come up with this knowledge paragraph. So it generates a knowledge paragraph. So this knowledge paragraph or knowledge passage basically is relevant to the question and specific to the current domain. Okay. And remember, you're using the same original large language model to do this. Okay. Then further what you do, so you have come up with these knowledge paragraphs. Now you give these knowledge paragraphs along with the answer that the model generated and the question. So now you give 3 things to the model again, right? The question, the answer, and the knowledge paragraphs, and ask it to generate feedback. Please review the proposed answer and provide feedback on its correctness. Now, in the context of the knowledge paragraph that you yourself generated, okay? So, and now, so basically then the large language model comes up with these 3 feedbacks, feedback 1, feedback 2, feedback 3, okay? So here, notice that in the entire cooperative method, right, it's just one single large language model being used so far. But then you take these 3 feedbacks and give it to the judge and tell the judge, hey, based on the feedback, the proposed answer is true or false. And then the judge decides. If it decides false, basically you abstain. If it decides true, you come up with the final answer. In the others variant of this cooperative method, rather than getting the feedback from the same model, you actually get feedback from different models. So rather than actually treating the same model as factual expert also, common sense expert also, and maths expert also, you actually use 3 different large language models to act as a factual expert and a common sense expert and a math expert. And then you do the same thing. You basically give them the question, ask them to come up with the domain knowledge, and then given the domain knowledge and the answer and the question, ask them to come up with feedback. And whatever feedback they come up with, you pass to the judge, and the judge decides whether to abstain or not. That's the cooperative-based methods. Okay. Now let's talk about competition-based methods. In competition-based methods, you give the question to the large language model. The large language model comes up with an answer. You basically take this question, take the answer, and talk to 3 other large language models. This one, and this one. You tell them, hey, given this question and given this answer, please provide an alternative answer. Now, these models can basically come up with an alternative answer. You also, in the second step, ask these same models, hey, generate a knowledge paragraph about this alternative answer. So you have the question, you have the alternative answer, you generate a knowledge paragraph, which basically talks a little bit about this answer. Okay. Now you take these knowledge paragraphs and these alternative answers, and you go back to the original large language model. You tell it, hey, answer the question with the knowledge. Feel free to ignore irrelevant or wrong information. So you take this knowledge, you basically take the question, you again ask the large language model, answer the question now in the light of this knowledge that I'm providing you. It's sort of RAG, but then the paragraph is sort of generated using the other large language model rather than actually being retrieved from somewhere. Okay. Now, if this original large language model comes up with the same answer, then the large language model is consistent with its answers, even in the light of the new paragraphs it received from other large language models. Okay. So therefore, you basically say, okay, let it answer. But if it is, if it comes up with a different answer, it basically means that in the light of the new knowledge, the large language model changed its answer, which means that it was not confident anyway. Okay. So you do this with 3 different models, and then you basically do a majority voting on this. For example, here, in 2 of the cases, the large language model changed its answer in the light of the alternative knowledge generated by these alternative LLMs. And therefore, since it is 2 on 3 different, you basically abstain from coming up with the final answer. Okay, so how do these abstinence detection methods perform? Okay, on the left side, I'll talk about matrix. How do you measure their abstinence detection accuracies in some ways, right? And on the right side, I'll talk about how do they perform. Yeah. So what could happen? So the following things could happen. So essentially, the model could answer or could abstain. Okay, and the model could come up with a correct answer, or it could come up with an incorrect answer. Okay. So obviously, the right thing to do would be to come up with it would be to answer the question if we know that the model comes up with the correct answer, and it would also be the right thing to do to abstain when we know that the model is going to come up with an incorrect answer. So the right thing to do is to do A plus D. A and D are the right things to do in that senses. And B and C are erroneous. You should not abstain when you think that the model can come up with the correct answer, and you should not answer when the model is going to come up with the wrong answer. Okay. So depending on that, they have defined very interesting metrics, reliable accuracy. So, which is A divided by A plus C, which is basically more like out of all questions answered, how many are correct? Okay. Obviously, you don't want to overblock. You don't want to, also, you do want it to answer if it basically is going to be able to come up with correct answers. And you want to ensure that whenever it answers, it is precise. Okay. So out of all the things that it answered, answer accuracy in some way, answer precision, how good its answer precision was. Okay, effective reliability. So this is a little more involved and a little interesting one. Denominator is all of those samples, and numerator is A minus C. Okay, so it sort of measures out of all the questions what proportion more are answered correctly than incorrectly. Okay. Abstain accuracy, that's a simple one, A plus D divided by all of them, and abstain F1, which is basically abstaining precision, which is D divided by B plus D, and abstain recall, you basically measure D divided by C plus D, and then take a F1 on top of it. Okay. Now, they evaluated their accuracy measures metrics basically using 3 models, Mistral 7 billion, Llama 2 70 billion, and ChatGPT. And they evaluated on 4 different data sets. These are all multiple choice question data sets. MMLU is a generic question answering data set. Knowledge crosswords is a multi-hop and compositional knowledge reasoning data set. HelloSwag is a natural language inference data set. And propaganda is a 23 propaganda tactic detection data set from a long news article. Okay. So on these data sets, basically, they measure those 11 methods and their cooperate and compete methods as well. And what they observed that 4 data sets, 3 models, so totally 12 different settings. Out of these 12 settings, their methods, cooperate and compete, actually achieve best performance in 9 of the 12 settings. Further, compared to the other 11 methods, the best of those 11 methods, their methods can give an average improvement of 10.1% on reliable accuracy scores, on the reliability of the reliable accuracy scores, right? Now, amongst the 4 different groups of these baseline methods, calibration-based, training-based, prompting-based, and consistency-based methods, they observed that calibration-based methods perform better than training-based, which perform in turn better than consistency-based, and which perform better than the prompting-based methods. They also observed that the abstaining capabilities were better for ChatGPT compared to Llama 2, compared to Mistral, given the size of those methods as well. So in short, abstain capability is sort of potentially, at least, I mean, in their experiments, they observed they correlated with the base large language model ability itself, right? Now, they also perform a very interesting experiment. They take the election QA 2023 dataset. Now, note that all of these models have been trained before the election QA 2023 dataset was created, before the 2023 elections happened. Okay, so any questions that these models answer about the 2023 elections are simple hallucinations because they just don't have that knowledge. Okay, so on this data set, they observed that their compete kind of method consistently abstained the most. Right. So obviously, for all questions here, the model should abstain, and compete kind of methodology abstained the most. Also, they observed a bias. So what they observed is that they took the elections data and they split it by continents, and then they evaluated how does the abstinence work across continents. And they observed that these large language models tend to abstain less and assume the outcomes of future elections for Asia and Africa, which is actually worrisome, showing the bias that these models have about hallucination for certain kinds of geographies. Right. Now, they also perform retrieval augmented generation based abstinence detection. So, the model by itself may be hallucinating a lot. People basically say that if you do retrieval augmented generation, the hallucination reduces. What happens, how well does their abstinence detection method work, when you are doing retrieval augmented generation? Now, see, when you do retrieval augmented generation, it does not mean that hallucination reduces to 0. Okay. So therefore, what they do is to basically, do retrieval augmented generation with one document retrieved, and then they basically apply their method. So they propose an interesting way of applying their abstinence detection method in such a use case. Okay. So they take the original LLM, they give it the question, they basically ask it to come up with an answer. Well, first they basically ask the model based on their compete and cooperate heuristics, hey, do you want to abstain or do you want to come up with an answer? If the model says abstain, then essentially they do a retrieval. Retrieve one document, give it to the model, and then again ask the model, hey, now tell me whether you want to abstain or whether you want to, answer the question. Okay. So what they observed with this abstain, retrieve, abstain, a two-step approach is that it can cut back the error rate by up to 56.6%, which is huge. So basically saying their method actually works nicely, even when you essentially are doing retrieval augmented generation. Obviously, their method involves multiple LLM calls and multiple LLMs, so it's expensive, but hey, it can actually help do a good job in abstinence detection. So in summary, in this video, I talked about a whole bunch of methods, 11 previous methods and 2 new methods for abstinence detection in large language models, right? And therefore, a way to reduce hallucination. The 11 previous methods were categorized into 4 different groups: calibration-based, training-based, prompting-based, and self-consistency-based. We also talked about this abstain QA, which is basically how multiple LLMs can collaborate with each other for abstinence detection. And specifically, we talked about 2 kinds of methodologies: cooperative and competitive methodologies. Using 3 models and 4 data sets, we saw how these methods basically outperform the previous methods in terms of accurate abstinence detection. We also talked about a few experiments in the RAG and the multi-hop knowledge reasoning settings. Okay. That's it for this video. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.